In previous modules for tooth cutting, we talked a lot about having the proper correspondence between the type of blade that we're using and the material that we're working with. So we really move from the materials that we're going to be working with, so that's the material type and the thickness of the cross-section of those materials. And we take that information, which informs our choice of what's an appropriate blade for this tooth cutting procedure. So today we're going to be looking a little bit at metal cutting hacksaws. I've got 3 hacksaws out on the table. We're going to look at sort of the pros and cons of these different models and the evolution of the design of these and what some of those improvements have made possible. We're also going to look at using these around a specific project that we have here, because it's easy enough to talk about how these tools work, but I think that it's really to see how that practice is applied to a specific project is sometimes makes that experience a little more meaningful or a little easier to understand and relate to what our potential application of those things are. So let's take a look at what we've got going on here. So we have a blacksmith's vise here that is that's missing a part or a component that's used to hold this yoke in place, so that when this is oriented properly and it's vertical, that this yoke rests on the table and the leg goes down to the ground. And that yoke slides up, which wedges against the body of the vise itself. So we're missing this piece in here. So the first thing I had to do is go in and make some accurate measurements of the opening that this is that we're working with. So if I just had a ruler, I could come in and I could take a reasonably accurate measurement of this space using a ruler, but really the one of the most effective tools for getting measurements of inside dimensions are things like inside-outside calipers like this. It really let us get in and feel and see what that opening of the space is. And again, another inexpensive alternative that is I think they're probably less than $10 of these veneer calipers that give you the ability to do both inside measurements like we have here, and you can do outside measurements here. So, and we also can measure we have the ability to also measure depth in that through space as well. So it's for $10 you're getting a lot of capacity out of a tool like this. So once I've got that all, those measurements noted on a piece of paper, then I can go to do a little bit of layout on my material. And so, again, you've heard me say this before, but combination square is one of my favorite tools to use for layout. So I could take my measurement and translate that over to this position on the combination square, lock that in place, and then I'm able to take, if I'm looking to get a really precise mark on the surface, I could use a scribe to etch a line into the surface and slide along the length like that, or I could make a mark and then strike that line up the length. And if I don't really, for what I'm doing right now, I don't really need that high level of precision, because I'm actually going to have to come and clean this up filing. So I'm actually going to cut it slightly oversized. So a Sharpie would work very well just to go ahead and do the layout on that surface, right? That's going to be a fine enough line for what I'm trying to do. So once I've got my line laid out on the surface, I want to make sure that that's secured to the table. And with almost every tooth cutting system you use with probably with almost all materials, but especially with metal, we're always going to have to use a work holding system to clamp or secure that material in place, because using hacksaws, using files, and a lot of other tools require you to have two hands on the tool. But even if it wasn't a requirement, it's hugely advantageous because the mechanical advantage of using two hands gives you much better control over what you're doing. So let's pop in for a little a closer look at hacksaws and the different kind of blade options that are available for these. So, this is sort of the, here's the original recipe right here. I mean, this is, you can still find hacksaws that look like this, that are made with these same design parameters. We have a wing nut on this end. Left is loose, and counterclockwise brings that screw forward, and that allows me to then take the blade off and swap it out for another blade. It is also not at all unusual to find in hacksaws like this, especially the better quality ones, that they can accommodate different lengths of blades. The two standard lengths are 10-inch and 12-inch blades. So you're able to make an adjustment to the length of blade that's accommodated by, this actually has 3 positions in it. And so you can slide to these different notch positions to accommodate different lengths of blades, right? So like many things, the quality of the construction of that tool and the design of that tool has a lot to do with how well that tool is going to work. So if you don't have a strong frame that's built out of sturdy material, then your blade is not going to be able to maintain the rigidity it needs to be able to effectively cut through cross sections of material. So, one of the things you're looking for in that frame is that it looks like it's built out of good sturdy material. Another thing that you're looking for is that the handle is designed in such a way that it's comfortable to grip onto, right? And even though this is a really old saw, it has a handle that is a pretty nice fit to the hand and comfortable to hold on to. So that's going to make a difference when you're using that saw. And again, remember, teeth always face forward. We're cutting on the forward stroke. So a more contemporary version of that particular hacksaw is this guy, that instead of using a wing nut, it has this tensioning rod on the top that allows you to exert tension on the blade very easily. And again, you can see it has an ergonomic handle, and but this is a fixed length. It cannot be adjusted to different lengths of blades. So, and then last but not least, you have like a what we would typically refer to as a commercial or contractor's grade hacksaw. And so this is not just giving us a really nice ergonomically designed handle, but it's also giving us a head that's got a really good position to grip on this end of it. And these are what are called high tension frames. It says this high tension frame takes full advantage of the special qualities of Nicholson bimetal alloy blades. Extra blades can be conveniently stored in the frame itself. So here we've got blade storage up in here, and we've got this ergonomically designed frame that gives us the ability to ratchet tension onto that blade, and I'll show you how that's done in a second. And also some of these saws will also have a secondary position that where that saw blade can be mounted. So here the blade is mounted in a parallel relationship with the body of the saw, but there's a 45 offset here that also would allow you to get into in unusually tight corners, some unique circumstances where you would benefit from being able to switch that angle of the blade. So there's let's see if I remember how to do this. It's been a little while, but you push into the handle, push up on this, and that takes you can see there's that pivoting, ratcheting component here that allows you to put tension or draw back on that blade. And so it's a really quick and easy change of the blade on a saw like this. Okay? So for the thickness of the cross section of this particular material, I'm choosing the coarsest blade I have available, which is an 18 tooth per inch blade. And although an 18 tooth per inch blade is a little fine for going through this 3/8 inch thick cross section, the way that I orient the blade relative to the material will improve my outcome. So in other words, if I was trying to cut through the width of this piece of material with an 18 tooth blade, it would take forever and a day. It would take a tremendous amount of force to be able to do that. But if I come in at a high angle like this and cut through the material, then the correspondence between those 18 teeth per inch and this 3/8 inch cross section are a little more harmonious. So, so to start that cut, what I'm going to want to do is I'm going to change up my camera angle so you have a better view of what's going on for this part right here. So, as I mentioned before, it's really important that your work be securely held in place so that you can have two hands on the tool at all times. I want to make sure that I've got my proper eye protection on to protect me against the small chips of debris that are coming off of this. And in some cases, it might be advisable to make sure and have proper hand protection on as well, in the form of some properly fitting material handling or vibration dampening gloves. So the teeth are cutting on the forward stroke, but in order to establish my path, I'm actually going to go in the opposite direction. I'm going to pull backwards gently just to establish that cut path. So I'm not using a lot of downward pressure, and I'm just drawing back until it starts to, can we see that little notch that it's forming on the surface? So it starts to gently establish that path without a lot of downward pressure. Once I've established that path, now I'm ready to start to make forward strokes. And it's really about having the right balance of downward pressure and forward stroke. So I'm going to be lightly bearing down as I push forward, and then I'm going to just take all the pressure off, or most of the downward pressure off, and draw back. Cut, draw back. So I'm pushing on the forward stroke, pushing it out of the way, and then lightly drawing back, keeping it in that slide. Every once in a while, I might stop and see how I'm doing in maintaining my path. If I feel like I'm coming off my path a little bit, then I can go a little longer in my orientation to help draw that line out along that path, and then go back into a more vertical position. So you can see that even with a simple tool like a hacksaw, you can make pretty accurate cuts in fairly thick material. It doesn't require a tremendous amount of strength. It does require some endurance, do a cut like that in one go. But it does have marks on the surface that reflect the contact with the blade, and that is something that we're going to be able to smooth out and take this down to our exact size using another tooth cutting system, our hand files.